Hey everyone, and welcome. Today we're going to peel back the layers on software testing and really demystify a key concept called condition coverage. So if you've ever wondered how developers make sure the logic buried deep inside an app is actually solid, you are in exactly the right place. So here's how we're going to tackle this. We'll start big picture, with the main philosophies of testing. Then we'll define white box testing, figure out how we measure it, and then zoom right in on our main event, condition coverage. After that, we'll wrap it all up with why this stuff really matters. Okay, first things first, we gotta look under the hood. To really get a handle on condition coverage, we first need to understand that there are basically two fundamental ways to think about testing software. Think of it like a car. Black box testing is like being the test driver. You hop in, you turn the key, you hit the gas, you slam on the brakes. You don't care how the engine does its magic, just that the car works like you'd expect it to, right? White box testing is the total opposite. Now, you're the mechanic. You pop the hood, you're looking at the engine, checking the wires, inspecting all the internal guts to make sure the logic and the structure are sound. And for our journey today, we are definitely popping the hood. So let's stick with that under the hood idea. What exactly is white box testing when we get right down to it? At its heart, white box testing is all about one thing: the source code. It's a method where the tester can see everything, the entire code base, and they use that knowledge to build super specific tests that check all the program's internal pathways, its logic, and its overall structure. So what are we actually looking for when we get under that hood? Well, we're tracing the code's logic and flow, making sure it goes where it's supposed to. We're also tracking how data moves around, we're hunting for security vulnerabilities, and making sure that when things go wrong, the error handling is graceful and nothing just breaks. It's about making sure no path is left unchecked. And this leads us to a really important question. If we're testing all this code, how do we know if we're doing a good job? How can we be sure we've tested enough of it? Well, that's where measurement comes in. The main way we measure this is with something called code coverage. And it's pretty simple, really. It's just a percentage that tells us how much of our source code was actually run or covered by our tests. A higher percentage usually means our testing was more thorough. Now, code coverage isn't just one single thing. There are different levels of detail, different ways to slice it. You can check if every single line of code was executed, that's statement coverage. You can check if every major fork in the road was taken, that's branch coverage. But the one we're going to zero in on, the most detailed of the bunch, is condition coverage. All right, we've made it to the core of this explainer. Let's dive deep into the specifics of condition coverage and see how it tests the absolute smallest, most fundamental pieces of our code's logic. Okay, so here's the key idea. Condition coverage looks at every single tiny part of a decision, any little statement that can be either true or false, and it makes sure that each one has been tested both ways. So if you have a line that says if A is true and B is true, condition coverage isn't satisfied until you've run tests where A is true, A is false, B is true, and B is false. It's about testing every single ingredient, not just the final dish. The best way to really get this is to just walk through an example. So we're going to follow a simple three-step process. We'll look at a bit of code, we'll pick out its logical conditions, and then we'll build the tests we need to cover them. Easy enough, right? Okay, check out this code snippet. It says if x equals 0, or that's what those two vertical bars mean, y equals 0, then it prints 100. Else if z equals 0, and that's the double ampersand, w equals 0, then it prints 200. And if neither of those is true, it just prints 300. So let's break this down. That first if statement has two little questions it's asking, joined by an or. Is x equals 0, and is y equals 0? Those are our first two conditions. The second if has two parts joined by an and. Is z equals 0, and is w equals 0? And those are our other two. So all in all, we have four simple individual true or false conditions we need to test. All right, now this table is where it all comes together. To get that 100% condition coverage, each of our four conditions has to be true at least once and false at least once. So let's see how we do it. Look at test case 1. We make x equal to 0. Boom. Condition 1, x equals 0 is true. Check. In test case 2, we make y equal to 0. Now condition 2 is true. See the pattern? Test case 3 makes condition 3 true, and test case 4 makes condition 4 true. So those four tests got us all our trues. But what about the falses? Well, look closer. In test case 1, y equals 0 is false.
In TC2, x equals 0 is false. Each test is pulling double duty, and by the time we're done, every single one of those 4 conditions has been evaluated as both true and false across our set of tests. That is 100% condition coverage.
So now that we've seen how it's done, let's talk about why it's so important, and maybe more importantly, what common mistakes and traps to watch out for. The biggest advantage here is just how thorough it is. You are literally guaranteeing that every single little logical lever in your code has been flipped both ways. This is amazing for finding nasty bugs that hide inside complex logic, the kinds of bugs that simpler testing methods might just blow right past. And that, of course, leads to way more reliable software. Now, here's where people get tripped up all the time. They mix up condition coverage with branch coverage. So branch coverage just asks, did we go down the if path and did we go down the else path? It only cares about the final destination. Condition coverage is way more detailed. It asks, inside that if statement, did we test every single little piece that made up the final decision? It's the difference between checking if a car made a left turn versus checking if the driver looked in the mirror, used their turn signal, and then turned the wheel. See? Much more granular. It's also super important to keep it real. Hitting 100% condition coverage feels great, but it is not a magic wand that makes your code bug-free. All it means is that you tested the conditions you wrote down. The logic itself could still be wrong, or you might have totally missed some weird edge case, like what happens if a user enters the biggest number possible. It's a fantastic tool, but it's not a perfect guarantee. Whew, we have covered a lot of ground, from high-level ideas all the way down to the nitty-gritty of a test table. So let's boil it all down to one final crucial point. If you only remember one thing from all of this, let it be this. Condition coverage is all about testing the small, logical building blocks of your code. It's about making absolutely sure that every tiny piece of every single decision has been thoroughly checked out. And that leaves us with this final question to chew on. If 100% coverage doesn't promise us perfect, bug-free code, what does it actually guarantee? Well, it guarantees a certain level of rigor. It's a promise that we have been incredibly diligent in examining our own logic, piece by tiny piece. It isn't a guarantee of a perfect destination, but it's a powerful statement about the quality of the journey. Thanks for digging into this with me.